Okay, so here we have a mini lesson on how to draw Bohr Rutherford diagrams. Last night, or last day, or whenever you watched the last lesson, you probably remember that you learned about the three subatomic particles of the atom, the protons, electrons, and neutrons. The Bohr Rutherford diagram is a model, okay, which is basically just a representation or a diagram of a neutral atom. But in grade 9, it's good to know how to draw these things because it kind of shows us how many protons, electrons, and neutrons there are and where they're located based on the model that Bohr and Rutherford came up with. Okay, this is an important value, an important point to ponder, is that all the values that you need are all found on the periodic table. Okay, so all the information that you need is found in the periodic table. So just to recall, protons, which typically carry the symbol P+, that's the atomic number. So how many protons does something have? Well, you look at the periodic table and you find the atomic number. That's how many protons it has. Electrons, E-, same deal. How many electrons does something have? Oh, I wonder what its atomic number is. That's going to tell you the number of electrons that it has, because what we're doing with Bohr Rutherford is that we're representing neutral atoms, right? So the number of protons is going to be equal to the number of electrons. Neutrons is a little bit trickier. You take the atomic mass, whatever it is, you round it off, and then you subtract from that the atomic number. Why is because the atomic mass is mainly due to the fact that protons and the neutrons contribute to the mass of an atom. So if I want to find out how many neutrons only, I take the number of protons plus neutrons and I just subtract off the number of protons. So these are three handy-dandy little reminders that are going to help you. So let's get right to a diagram. We want to draw a Bohr Rutherford model of potassium. Okay, we know that that's symbol K. And if we were to look on the periodic table, we would see that its atomic mass is 39.0983 and its atomic number is 19, right? All these values we got from the periodic table. And if you're wondering where they are, all we need to do is scroll down. Here's the periodic table. Potassium is K. And what we see right here is we see the atomic number and the atomic mass. Okay, this is 39.10. Obviously, we're going to round that off. So let's go back to our note here. Okay, the number of protons. The number of protons we saw from above is the atomic number. That's 19. Okay, so this is the same as the atomic number. Make sure you write this down so that you have it. Okay, the number of electrons. Oh, well, that's 19 as well because it's the same as the number of protons. Okay, there's no negative charge, there's no positive charge. Same as the number because it's a neutral atom. The number of neutrons is going to be the atomic mass, which was 39.10, so it's the atomic mass rounded off minus the atomic number. Okay, so let's actually do that math. So the atomic mass was 39.10. We can come over here. 39.10. If you want to round this to the nearest whole number, we're going to round it to 39. Now we subtract the atomic number, which is 19. 39 minus 19 is 20. So that means the number of neutrons is 20. So what we have now is we have a series of steps. So we've just completed step 1, is to determine the values for those subatomic particles. So we're kind of through with step 1, which is good. That's a good thing to be done with. Now next we draw the nucleus. Okay, we draw the nucleus of the atom. Use pencil so that corrections can be made. Here's an example of how we draw the nucleus. The nucleus is a little circle like this, and then inside it, we write the number of protons and the number of neutrons. So we can write 19 protons and 20 neutrons. Okay? And that's how we do it. That's the nucleus. That's what a nucleus looks like. All right. Next, so that's step 2. So we've drawn the nucleus. That came next. And we know that neutrons and protons are in there because that's what goes inside of a nucleus. We learned that in the last lesson. Okay. So for potassium has 19 electrons. So we must now draw our energy levels. We have to draw our electrons and energy levels. And we know that there's 2 electrons inside the first energy level. So we have with our nucleus, and this is what I'm going to do. You can just copy this. You can't do it as easy as I can. But here, I'm going to draw it. I'm going to draw it kind of down here because this is where we're going to do it. So in our first nucleus, or our first energy level, we have 2 electrons. Okay, so here's the 2 electrons. And we know that these energy levels, they're kind of like orbits. And so we're going to draw this like this, in kind of like this rounded way. And then we continue to fill up. So the first one's got 2. The second one has 8. The third one has 8. And how many are we at? 2 plus 8 is 10. Plus another 8, that's 18. We have 1 more electron to go. So our final energy level is just 1 electron. And there is the approximate Bohr Rutherford diagram for potassium. Okay, so there it is. All right. What you're going to be tasked with is to draw the Bohr Rutherford diagrams for basically the first 20. You have a handout that you'll be given. Okay, and in here we've got all of the different elements with their data. Use your periodic table and make your way through this sheet. That's the first step, and that kind of satisfies step number 1 for all of the ones that you have to do. Then you're going to use the sheet. You're going to draw the nucleus, and you're going to start filling energy levels, and that should kind of take you the rest of the period. So this is the work that we're doing today. Now that you've seen the lesson, good luck.